Cool. Find all possible combinations of k numbers that add up to a number n. Given that the numbers from 1 to 9 can be used, and each combination should be a unique set of numbers. All numbers will be positive integer. The solution set must not contain duplicate combinations. Okay. So this is they want all possible numbers. Okay. So I think in general this is just pretty straightforward recursion problem. Um, yeah, I mean, I think the thing that what is max n? Okay, can be used in each combination. Huh. I think the one thing that is unclear and what I was looking for is kind of the problem constraints, like what is the max k and what is the max n, which is kind of unfortunate actually that they don't show you or like they don't give you because it because it gives you different possible solutions. But I think in this case, I would just it's just straight recursion, right? You basically maybe actually like Python. Yeah, I think you just essentially does a for loop and then recurse on it. I think yeah, okay. So let's kind of get started. So what is the state of this recursion? I think at each state you just take a number and try to go to the next one. I think there's some shortcutting algorithms that we can do. We'll kind of see if we need it. This is one of the issues with kind of like not. Oh, I guess there's actually a constraint that you have to kind of figure out for yourself. Now that I see that there's no. I don't think this is each combination with unique set of numbers. I think this is worded a little kind of also poorly. I think like for example, like I would have maybe guessed that like for k equals 3 and equals 9, you could do 3, 3, 3, like 3 plus 3 plus 3, which but clearly it's not listed an example, so then it's you cannot do that. But that and given that you can only use numbers 1 to 9, there's a bit of a I mean, like an implicit constraint on the possible numbers that n can be, because I don't know because if you sum up this 1 to 9, which is what 9 choose 2 is like 45 or something like that, right? Either 45 or 36, I don't remember. But so that, and even in that case, you just like you imagine it's like essentially like a linked list of 1, 2, 3, 4, 5, 6, 7, 8, 9. So the combinatorics is not that high. It's a little fuzzy to. I mean, usually these kind of problems they ask you to do dynamic programming and ask you for the number of count, but this particular one they ask you actually for the actual output. So I'm just going to assume that the return value are small enough. Otherwise, this will be a really really hard problem. I think my first goal, I'm going to try it without like any Python specific optimization. I'm just going to use do I? No, I guess you're given k, so I guess that's okay. Yeah, so I guess I'll do some optimization prematurely, but we'll kind of play around with. So for this, I'll just so we'll kick off the recursion by some three from kick off with 0 kn. Okay. Okay. Do I want to do it like that? Yeah. Okay. Is that okay? Yeah, that should be okay. Oh, yeah. Oh, and I'll explain what these are in a minute. Because I'm writing that code now. But basically, this just help us kind of kickstart the recursion. So the first number is just like the last, or not. So the first 0 is just the biggest number that you cannot use, almost like a minimally exclusive set kind of thing, but not really. Okay, fine. I'll just call it last for now. And this is just like the array is like a in progress array, so maybe I'll call it oh, I just forgot what language I'm in. So some of this is without typing. This is maybe actually a little bit more confusing, but it's just like the stuff that's in progress. I'll just call it current, I guess. And then K and N is just the same as in the problem. So now for I in range of last plus 1 to n. Oh, I think I forget to do sum. I mean, the sum is actually like you could calculate it by keeping track of current, but do I want to do it that way actually? Yeah, I mean, no, it's okay. I'll do it later. I mean, so there's some like shortcuts around these things that kind of allows you to return early, and maybe that solves some, for performance purposes, it'll be better. But at this first go, I just want to kind of make sure it works, and then we can play around the optimizations later. Do so. How do I want to return the? Okay. So result is equal to, and then return results. I know there's an S. So here we do. Let's think about this. I think I'm just going to abuse the global a little bit, just so that we don't have to kind of pass stuff all around a lot. Is it sub results? Is that how? Man, I don't remember Python 2 syntax. But okay, well, just to be clear then. Man, that did not make that clear. Cool. So now for I is equal to range plus 1, you want to just do a recursion on so the last number would be I, and then current is, well, I guess, what is the index? Man, there's a lot of, I don't want to keep another variable. Okay. No, that should be okay. Sorry. Because we could start from K. Yeah, okay. Kind of K minus 1 is equal to I. So this will actually be backwards. So actually, in that case, does that work? I actually don't remember if range goes backwards. Okay, I'll look at it. Fine, let's just actually do it the correct way. I'll just assume the result I get are backwards, and either we could return them or whatever. Okay, so we return current, or you recurse on current K minus 1 because now you have one fewer K. That's not true. Yeah, one fewer K, and N minus I because now it's just lower. Base case if N is equal to 0, so yay. So we add to result. Get back to this in a bit. I just want to make sure I get the other states out of my head. If n is less than 0, you return early. So actually, you don't need to return results. This abuse self.results. Are those the only two cases? Oh yeah. No, so I lied. Well, this is definitely would be a shortcut. But if k also has to be 0 for this to be true. Otherwise, if n is equal to 0, or k is equal to 0, then you just return as well. Just to be clear. Okay, and then now self.result start append current. So I think this should be roughly right. There might be some, I mean, I expect this answer to be actually incorrect in that like this is reversed because I'm doing this in this order, or like I'm populating current in this order. But let's see, just to see if we're in the roughly right ballpark. Well, I got nothing, so uh, hmm. Do we even hit this at all? Am I? Well, let's want a smaller case of 1 1. Okay, so maybe I'm just doing something really silly. Um, mm, mm, sure, pending, but it probably doesn't otherwise. Okay. Guess now we just print out the states then. Fine. Um, does that work for an array? Yeah, hopefully we'll see. Okay, so it goes to 0, 9, 1, 1. Oh, so last is 0. Am I doing the right ends? I guess I should stuff on range and indexing. I'm always just a little rusty about. So prior to this, I actually haven't, or prior to Wednesday, I actually haven't done these kind of problems in like about a decade, to be honest. Other than like a quick fresh me up, so I'm a little rusty on this stuff. So okay, so maybe that's why the range is it's not even printing anything. Oh no, oh well, does it even get here? It should get hit to this far, right? At least. Just really bad. Oh, wait. Is it because I am confusing range and range 2? Okay, so it does do this. It just doesn't even go to range. Is my oh well, in this case it doesn't because last plus 1 is no. Last is 0, so now it should go from 1 to 1. Did I just forget a plus 1? Because okay, so that worked for that case. Let's try 3 and 7. Man, if you're on the stream and you're following and you wonder why I'm super cautious about off by 1 errors, well, this is why, because I have a lot of off by 1 errors. That's like my arch nemesis, and I don't need to print this anymore. But okay, but we still have some work to do. 447. How does that even fit? Okay, where's my other print? Okay. Oh, well. Hmm. So k minus 1 is equal to I. So maybe I'm populating the. So it tries 1, 2, 4. Nope, which is correct. Wait, why? Why do you not append there? Oh, man, this is. Why does it append 447? Oh, okay, fine. It's it's because I do a soft copy. Okay, that's fine. So yeah. New result is equal to for x in I in current result append I and then we want to revert it. Okay, maybe I just do something like something like that. Oh, new resource. Oh man. Okay, so that looks like it's okay. Let's try the other case. Okay, cool. So that looks good. I'm going to click submit. Let's see if that's good before. Oh no. Oh, whoops! I forgot to restrain this by. That's the thing that like it is a very stupid mistake, and that I made it, and that I should like be able to catch it. I really wish they didn't tell me what the error was, because yeah. So the error is that I should not return anything, or this should be at most 9. 9, maybe 10. It's either 9 or 10. Okay, well let's do 10 now, and then I could test it manually. Oh, whoops. Oh man, the auto parentheses keep on eating a paren. Is it just max? Oh, is it big? No. Man, I do not know how to get math.max apparently. Well, math.max maybe 513. 512. Too late to switch back now. Okay, fine. It looks okay. So this weird case. So now it's returning the incorrect answer for. Is it just not? Huh. Wasn't this well? I actually maybe it could have been wrong before. I wasn't double checking, but it should go to the 9, right? But how does this even get from? Because I would be the smallest. Man. Huh. I mean, I think this is one of those things that there's probably like a reference not fixed somewhere, but maybe I could do. Would that make it change? I don't think so. Well, okay. So at least it makes that clear that there's some like reference issue with current. Man, full of $30 today. Man, how many bucks can you get for 20 lines, 29 lines of code? Huh. It only takes. Is there something weird with? No. Huh. So there's something weird where it's kind of not reusing it right. Okay, I think I have a similar case that. 1, 2, 4 maybe. Because I'm thinking maybe it's because 126 and 135 share the same one, that there's some weird thing with the recursion, but or do I change k? I mean, I don't change any of the k, and only thing I change should be current, and last should already just be I. Huh. Hmm. Okay. Well, I mean, it's only one thing to do, which is to print everything again. This is, and meanwhile, still getting spam calls from random countries. But maybe I just want current. This is gonna be a longish recursion, but no. Hmm. That looks what I would expect. Now let's try the v9 case. So 1, 1 to 6, and then it. So when it recurs back from 1 to 6 after copying. Oh, I see. I think it yeah. Oh man, that is actually kind of crazy. But okay, so I think I just forgot to return, and therefore this part was manipulating the current index again. And I think the first time I overlooked it as well. I just kind of it looked roughly right on the scan. Okay, let's submit and see if that works. Okay, well, wait, what? It's wrong for this still? Man, I guess I should test that one. That's kind of embarrassing. You always check at least the stuff that you know to be wrong. But I thought I max 9'd it. Oh, this is not a max. This should be a min. Because you want min to be the... Okay, now I'm attempting to run code too soon. Is that a min 9 or min 10? But let me see if I could do 17. Because then that should be 8 plus 9. So, okay, so that does return. And then I want to try also was 19, and that would be 9 plus 10 if I get it wrong, but it should be nothing. Okay. A little bit more diligent. Oh my god. Well. This really should be straightforward, but unfortunately, it is not to be. Okay, so I have some subset of the answer here, but I'm missing some as well. 249. I don't. I mean, that's the thing that I was worried about with. If it's just another off by 1, I'm a little sad about it. Okay. Why is that? Actually, not quite sure. Why did 17 work before then? If I'm not quite sure. Okay, well, I mean, always submitted wrong 3 times. Let's see, how's the 4th time? Okay, fine. But so I mean, I think in concept we knew what we were doing right from the beginning, but there's a lot of silly mistakes. The obvious one being we let the digit goes higher than 9. So yeah, thanks. Yeah, maybe I just didn't look at it, but I think so. This one, no matter what, I should have been more careful. I mean, that's literally in the prompt statement. Like, it could only go from 1 to 9. Make sure you go 1 to 9. I think I had in mind, but then when I coded, I forgot about it. The other one is a little more subtle, and in general, I really try to do things stateless. Like I keep things stateless in yeah, in theory, I would try to keep things stateless so that your assumptions don't carry over from state to state. But and the reason why I kind of passed away here, the kernel array, is for a little bit of optimization so that like we don't create new arrays on every iteration, especially or every recursion, especially when you deal with recursion. That's the only time that I sometimes pass by reference is because for recursion, like these things can categorically get really big really quickly. But and then this would be more obvious because if it doesn't return, then it doesn't have a chance to kind of muck with future recursion as well. So okay, cool. So we did get that solved. Anybody have any questions, something like that? But yeah, thanks Eric for pointing out. I definitely missed that. I think I just, like I said, for the 3.9 problem, I definitely scanned it, and then I kind of missed the 8 equals 1 thing. Cool. All right.